The data package appeared without warning on November 15th, 2025, uploaded to 3 separate astronomical research forums within a 17-minute window. No introduction, no explanation, just a compressed archive containing 42 gigabytes of observation logs, spectroscopic data, and internal communication transcripts. The metadata told a story that shouldn't exist. Every file bore timestamps from early October, during the narrow window when 3I Atlas made its closest approach to Mars. More troubling still, the origin signatures traced back to systems within NASA's Deep Space Network, the vast array of radio telescopes that maintains contact with every spacecraft venturing beyond Earth orbit. The timing made it explosive. October 1st through 7th marked the government shutdown, when all official NASA communications ceased under federal funding lapse protocols. Public statements had been clear and consistent throughout that week. No observational data was being collected. Mars orbiting spacecraft remained dormant in safe mode. Ground-based telescopes had been powered down. The American contribution to 3I Atlas observation campaigns was simply on hold until Congress resolved their budget impasse and normal operations could resume. Every press release, every official statement, every public briefing had maintained this position without variation. Yet here sat dozens of high-resolution imaging sequences from Mars Reconnaissance Orbiter, spectroscopic measurements from the Hubble Space Telescope, radio telemetry logs from Goldstone Deep Space Communications Complex, all time-stamped during the shutdown period, all marked with classification headers that suggested coordination far beyond standard astronomical observation protocols. Someone had been watching 3I Atlas very carefully during those October days, and someone else had decided the world needed to know what they had seen. The forums where the files appeared catered to professional astronomers, not casual enthusiasts. These were communities where graduate students discussed thesis research, where principal investigators debated instrument calibration techniques, where peer review happened informally before formal publication. Access required institutional credentials, verified academic affiliations, demonstrated expertise. This wasn't some conspiracy website attracting attention seekers. This was the inner circle of planetary science, and someone had just dropped a bomb directly into their midst. The files spread with remarkable speed despite attempts at containment. Within 6 hours, copies existed on servers across 4 continents. Moderators deleted the original posts, locked discussion threads, issued stern warnings about handling potentially classified material. But the data had already escaped any hope of suppression. Too many researchers had downloaded it. Too many curious minds had begun examining the contents. Too many people had already seen things that raised profound and disturbing questions. Initial analysis focused on authentication. Were these files genuine NASA products or elaborate fabrications designed to spread misinformation? The technical specifications checked out perfectly. File formats matched known Deep Space Network standards. Instrument signatures corresponded to actual hardware configurations. The observation geometries aligned with known spacecraft positions during the relevant time periods. Metadata structures contained subtle implementation details that would require insider knowledge to replicate accurately. Every forensic test pointed toward authentic origin, but authenticity created far worse problems than forgery would have. If these files were real, they documented continuous surveillance of 3I Atlas during precisely the period when NASA claimed all observations had ceased. They revealed classification levels typically reserved for national security matters being applied to astronomical data. They showed coordination between civilian space agency assets and Department of Defense tracking systems. Most significantly, they contained preliminary analysis conclusions that deviated dramatically from every public statement about the interstellar visitors' nature and behavior. The anonymous source had included one additional file, a simple text document containing a single paragraph. It explained nothing about identity or motivation, offered no context for the data dump, made no explicit claims about what the files contained. Instead, it posed 3 questions. Why had these observations been classified? Why had their existence been denied? And what else about 3i Atlas was being kept from the scientific community and the public it served? Then came a final statement, brief and direct. The December observation window was approaching, when 3i Atlas emerged from behind the Sun and became visible to Earth-based telescopes again. Everyone would see whether the object had changed during its hidden perihelion passage. The leaked files would help people understand what those changes actually meant. The leaked observation logs revealed a surveillance operation that never should have existed. While NASA press releases claimed dormant spacecraft and suspended operations, the Mars Reconnaissance Orbiter had been imaging 3i Atlas continuously throughout the October 3rd closest approach. Every 93 minutes, as the spacecraft completed its orbit around Mars, its high-resolution imaging science experiment camera captured detailed views of the approaching interstellar visitor. The image sequences showed something far more sophisticated than a simple comet nucleus tumbling through space. Mars Express joined the observation campaign with its high-resolution stereo camera, collecting data from complementary angles that enabled 3-dimensional reconstruction of the object's structure. The European Space Agency operated independently of American budget constraints, so their participation raised fewer questions initially. But the leaked files showed unprecedented coordination between ESA and NASA systems, with observation schedules synchronized to the minute and data automatically routed through deep space network facilities for immediate analysis. This wasn't casual scientific cooperation. This was a planned, coordinated surveillance operation involving multiple space agencies operating under shared protocols. Most disturbing were the Department of Defense tracking assets that appeared throughout the logs. Military space surveillance systems designed to monitor satellites and orbital debris had been tasked to 3i Atlas observation. Ground-based radar installations, typically focused on near-Earth objects, had pivoted to track the interstellar visitor's trajectory with extraordinary precision. Even reconnaissance satellites in geostationary orbit had apparently been repositioned to maintain sightlines during critical approach phases. The classification markings on these military observation files carried Special Access Program designations, the kind reserved for the most sensitive intelligence operations. The data quality from all these sources exceeded anything previously achieved for interstellar object observation. Resolution reached sub-kilometer scales in some image sequences. Spectroscopic measurements captured emission lines across wavelengths from radio through ultraviolet. Thermal imaging tracked temperature variations across the object's surface with unprecedented detail. The combination created the most complete portrait ever assembled of an interstellar visitor, and that portrait revealed features that defied comfortable explanation. Internal communications included in the leak showed real-time analysis as observations accumulated. Scientists noted anomalies immediately. The trajectory measurements detected variations inconsistent with pure gravitational motion. Spectroscopic data revealed chemical signatures that didn't match any known comet composition. Thermal profiles suggested internal heat sources beyond simple solar warming. Most significantly, high cadence imaging captured outgassing events that followed patterns, repeating sequences that natural sublimation processes simply couldn't produce. The October silence hadn't hidden observational gaps. It had hidden observations that fundamentally challenged every assumption about what 3I Atlas actually was. Astrometric measurements from 3 independent observation stations painted an impossible picture. 3I Atlas wasn't following a purely gravitational trajectory. The deviations were subtle, measured in fractions of an arcsecond across millions of kilometers, but they were consistent and directional. Natural comets experience non-gravitational accelerations from outgassing, jets of sublimating ice that act like tiny rocket engines, pushing the nucleus in unpredictable directions. But those forces create chaotic variations that average out over time. What the leaked data showed was something entirely different. The course corrections were systematic, deliberate, and they all pointed in the same direction. The Mars flyby provided the clearest evidence. As 3I Atlas approached within 30 million kilometers, precise tracking from multiple Mars orbiters measured its position every few hours. Standard gravitational models predicted the trajectory with high accuracy based on the Sun's gravity, Mars' gravitational influence, and the object's measured velocity. The predictions were solid, tested against decades of asteroid and comet observations. Yet 3I Atlas deviated from those predictions by measurable amounts at specific moments during the encounter. The timing of these deviations matched periods of observed outgassing activity, which initially seemed to support natural explanations. Comets do push themselves around through sublimation, but detailed analysis revealed fatal problems with that interpretation. The magnitude of thrust required to produce the observed trajectory changes exceeded what the visible outgassing could possibly generate by a factor of 3. The direction of thrust didn't align with the observed jet orientations in imaging data. Most damning, the accelerations occurred in precisely the sequence needed to adjust the object's path toward its next destination. This wasn't random outgassing affecting trajectory as a side effect. This was propulsion being used for course correction. 3 separate tracking facilities confirmed the same anomalies independently. Goldstone Deep Space Communications Complex in California measured position through radio ranging. The Very Long Baseline Array used interferometry to determine coordinates with extreme precision. Even amateur astronomers with modest equipment detected timing discrepancies that matched the professional observations. The data formed a consistent pattern that couldn't be dismissed as instrumental error or analysis mistakes. Something was actively controlling 3I Atlas trajectory, making small adjustments to keep it on a specific path through the inner solar system. The leaked files included trajectory projections extending past the Mars encounter toward the upcoming Jupiter approach in March 2026. The nominal path, following pure gravitational dynamics, would carry 3I Atlas within 0.4 astronomical units of Jupiter, but wouldn't constitute a particularly close encounter by planetary standards. The adjusted trajectory, incorporating the measured course corrections, brought closest approach to 0.36 astronomical units. That difference represented targeting. Someone or something was steering 3I Atlas toward Jupiter with precision that exceeded coincidence. The spectroscopic analysis files contained data that rewrote everything astronomers thought they understood about interstellar objects. The Very Large Telescope's ultraviolet and visual Echelle spectrograph had captured emission spectra during 3I Atlas' closest approach to Mars, and the chemical fingerprints didn't match any natural comet ever observed. Standard comet spectra show water vapor, carbon dioxide, carbon monoxide, and simple organic molecules, all products of ices formed in the cold outer reaches of stellar systems. 3I Atlas displayed those expected features, but buried within the data were emission lines that shouldn't exist in natural cosmic chemistry. The nickel emission had been publicly acknowledged, though downplayed as merely unusual. The leaked files revealed why scientists had been so uncomfortable with that detection. The nickel wasn't appearing as atomic emission from heated dust particles, the normal process in comets. Instead, the spectral signatures matched nickel in molecular form, bound into complex compounds that required specific temperature and pressure conditions to form. Laboratory experiments had synthesized similar compounds, but only through controlled industrial processes. Finding them in a comet was like discovering precision ball bearings in a natural cave formation. Even more troubling was the iron to nickel ratio. Natural cosmic materials follow consistent elemental abundance patterns established during stellar nucleosynthesis. Iron should outnumber nickel by roughly 16:1 in any object formed from stellar debris. 3I Atlas showed the opposite pattern in certain spectral regions. Nickel emission dominated, while iron remained barely detectable. The only terrestrial materials with such inverted ratios are carefully refined alloys, produced through metallurgical processes that separate and concentrate specific elements. Stainless steel shows similar nickel enrichment. So do certain aerospace alloys designed for high-temperature applications. The organic molecule detections extended beyond simple compounds, like hydrogen cyanide and methane. The leaked spectroscopic data revealed absorption features consistent with polycyclic aromatic hydrocarbons, complex ring structures containing dozens of atoms arranged in precise geometric patterns. These molecules exist in space, formed in the atmospheres of dying stars and in dense interstellar clouds. But 3I Atlas showed them in concentrations and varieties that suggested something more than natural accumulation. The distribution patterns matched synthetic organic chemistry, molecules built through controlled reactions rather than random cosmic processes. Isotopic ratios added another layer of impossibility. Carbon-13 enrichment exceeded anything seen in solar system comets by factors of 2 to 3. Deuterium depletion indicated processing that preferentially removed heavy hydrogen isotopes. These signatures resembled fusion fuel preparation, the kind of isotopic separation required for controlled nuclear reactions. Natural cosmic chemistry doesn't produce such specific isotopic modifications. Those patterns require technology, energy input, deliberate manipulation of matter at the atomic level. The spectroscopic evidence stood independent of trajectory analysis or imaging observations. Chemistry doesn't lie. The molecules present in 3I Atlas coma told a story of refinement, processing, and synthesis. Whether that processing happened naturally through some exotic mechanism no one had yet imagined, or artificially through technological means, remained an open question. But the simple explanation that this was just an unusual comet from another stellar system no longer fit the data. The internal communications included in the leaked archive revealed decision-making processes that extended far beyond NASA's normal administrative channels. The discussion about whether to disclose the anomalous observations began within hours of the first Mars encounter data arriving at Deep Space Network facilities. Scientists recognized immediately that the trajectory deviations and spectroscopic signatures demanded explanation, and several research teams drafted preliminary reports for public release. Those reports never made it past internal review, stopped by directives that came from outside the space agency's regular command structure. References to established protocols appeared throughout the email chains and memoranda. The SETI post-detection guidelines, developed decades earlier to handle the discovery of extraterrestrial intelligence, provided a framework for managing information that could have profound societal impact. Those guidelines emphasized careful verification, consultation with international partners, and coordination with government officials before making announcements that might trigger public alarm. The problem was that SETI protocols assumed detection of radio signals from distant civilizations, not physical objects traversing our own solar system with apparent technological capabilities. Planetary defense considerations emerged as another justification for classification. If 3I Atlas represented reconnaissance by an unknown intelligence, disclosure could reveal Earth's observational capabilities to potential adversaries. Military strategists argued for maintaining information asymmetry, keeping any hypothetical observers uncertain about how much humanity had detected and understood. The logic suggested that appearing ignorant might prove safer than demonstrating awareness, at least until more data clarified the visitor's intentions and capabilities. National Security Council involvement became explicit in documents dated October 7th, the day the government shutdown ended. Senior officials from defense and intelligence agencies participated in teleconferences with NASA leadership, ESA directors, and scientific advisors from multiple nations. The discussions focused on managing information flow, establishing classification levels, and coordinating messaging across international space agencies. Consensus emerged that extraordinary claims required extraordinary evidence, and that evidence needed verification through the upcoming observation windows before any public disclosure. The scientific community found itself trapped between professional ethics and national security directives. Researchers who had spent careers advocating for open science and transparent communication faced orders to withhold data that could reshape human understanding of our cosmic neighborhood. Some complied reluctantly, convinced that premature disclosure without definitive proof would damage credibility more than temporary silence. Others questioned whether any government had the right to suppress evidence of this magnitude, regardless of verification status or potential social impact. The leaked files suggested that the anonymous source came from within this conflicted group of scientists. Someone had decided that the December observation window would arrive with or without official preparation, and that the public deserved access to existing data before that moment of truth. The leak represented a calculated violation of classification protocols, driven by conviction that transparency outweighed the risks of premature disclosure. Whether history would validate that decision depended entirely on what 3I Atlas revealed when it emerged from behind the Sun. The high-cadence imaging sequences from Mars Express revealed patterns that natural physics couldn't explain. Every spacecraft orbiting Mars captured images during the October encounter, but Mars Express had been programmed with an unusual observation schedule. Instead of taking periodic snapshots as the object passed through the field of view, the high-resolution stereo camera recorded continuously for 6-hour blocks, capturing frames every 11 seconds. This created time-lapse sequences showing the evolution of 3I Atlas coma and dust jets with unprecedented temporal resolution. What those sequences revealed challenged every model of cometary outgassing ever developed. Natural comets emit gas and dust through sublimation, ice turning directly to vapor as solar heating warms the nucleus surface. The process is fundamentally thermal, driven by temperature changes that follow predictable patterns based on rotation and solar illumination. Outgassing intensifies when freshly exposed ice rotates into sunlight and diminishes as that same region moves into shadow. The result is irregular but thermally logical, jets appearing and fading according to the simple physics of heating and cooling. 3I Atlas didn't behave that way. The dust jets activated in sequences. A plume would erupt from the sunward hemisphere, persist for exactly 11 seconds, then cease completely. 13 seconds later, a second jet would activate from a different location, maintaining emission for precisely 13 seconds before shutting down. Then 17 seconds of quiet before the next activation. The pattern continued through prime number intervals: 11, 13, 17, 19, 23, 29 seconds, cycling through the sequence repeatedly across multiple observational periods. The mathematical precision was absolute. Frame-by-frame analysis showed jet activation and termination, synchronized to within single-second accuracy across dozens of repetitions. This wasn't approximate timing that might result from some exotic thermal cycle. This was exactly timed emission, following a mathematical sequence that had no business appearing in natural phenomena. Prime numbers don't govern sublimation physics. Temperature gradients don't create precise integer second timing. Yet, there it was in the data, undeniable and impossible to dismiss as instrument artifact or analysis error. The spatial distribution added another layer of impossibility. The jets didn't emanate from random surface locations, as expected, from patchy ice distribution on a rotating nucleus. Instead, they appeared in a ring pattern around the equatorial region, evenly spaced like nozzles on some vast rotating mechanism. As the object rotated, different jets in the sequence activated in turn, maintaining consistent orientation relative to the Sun despite the changing geometry. The behavior suggested active control, systems monitoring solar direction, and triggering specific emission sources according to programmed timing. Energy calculations made the pattern even more troubling. The observed dust production rates during these pulsed events exceeded what passive solar heating could generate by significant margins. Maintaining jets at the observed intensity levels required either absurdly efficient sublimation from impossibly volatile ices or active energy input from internal sources. Natural explanations stretched toward breaking points. Artificial explanations became unavoidable. Something aboard 3I Atlas was timing these emissions with mathematical precision. controlling which jets fired when, and providing energy to maintain emission rates that sunlight alone couldn't sustain. The coma wasn't just active. It was breathing in patterns, speaking in prime numbers, demonstrating capabilities that transcended everything humanity thought it understood about how comets work. The Hubble Space Telescope observations from July 2025 had been released publicly shortly after 3I Atlas discovery, showing what appeared to be a typical, though somewhat elongated comet nucleus surrounded by a diffuse coma. The images satisfied initial curiosity and established basic size parameters, estimating the central body at somewhere between 0.44 and 5.6 kilometers in diameter. The large uncertainty reflected the difficulty of separating nucleus from surrounding dust, a common problem in comet observations. Those were the images NASA chose to share. The leaked files contained the images they chose to withhold. Advanced processing techniques revealed details invisible in the raw data. Hubble's resolution reaches theoretical limits set by its 2.4-meter mirror diameter and orbital altitude. But sophisticated algorithms can extract additional information through careful analysis of multiple exposures. Deconvolution processing removes optical blurring. Unsharp masking enhances edge detection. Difference imaging highlights variations between successive frames. When these techniques were applied systematically to the July observation sequence, structures emerged that shouldn't exist on natural comet nuclei. The nucleus showed geometric regularity in its overall shape. Natural comets are irregular lumps, their forms determined by haphazard accretion, collision history, and random erosion patterns. They look like flying mountains, all chaos and accident. 3I Atlas displayed bilateral symmetry along its long axis, opposing sides mirroring each other with precision that random processes don't produce. The symmetry wasn't perfect. Enough irregularity existed to prevent obvious artificial appearance in casual inspection. But statistical analysis of shape parameters revealed organization far exceeding what gravitational collapse and impact events typically create. Surface features showed even more troubling patterns. Enhanced imagery revealed linear structures running along the nucleus longitudinal axis, parallel lines maintaining consistent spacing across hundreds of meters. Cross patterns appeared at regular intervals, intersections forming at what looked disturbingly like designed locations, rather than random erosion channels. The features weren't dramatic, nothing so obvious as manufactured panels or mechanical components. Instead, they suggested underlying structure expressing itself subtly through surface topology, like seeing building foundations beneath gentle hills. Most significant were the bright spots scattered across the nucleus surface. Natural comets show brightness variations from compositional differences, fresh ice appearing brighter than dust-covered regions. But 3I Atlas displayed discrete bright features with sharp boundaries and regular spacing. They appeared in clusters of 3 or 4, arranged in patterns that repeated across different regions of the surface. The brightness temperatures of these spots exceeded their surroundings by measurable amounts, indicating either different composition or different thermal properties than adjacent materials. Thermal modeling couldn't explain the temperature distribution. Solar heating creates predictable patterns based on surface orientation and rotation. The bright spots maintained elevated temperatures regardless of their position in the rotation cycle, suggesting internal heat sources or materials. with exotic thermal properties. Either explanation pushed beyond comfortable boundaries of natural phenomena. The classification markers on these processed images indicated immediate recognition of their significance. Files bore special handling designations, typically reserved for national security imagery. Distribution lists included defense intelligence analysts alongside astronomers. Notations referenced further analysis requirements and comparison with classified reference databases. Someone had recognized these surface features as potentially artificial and had immediately elevated the observations beyond normal scientific channels. Hubble had seen something in July that transformed 3I Atlas from interesting interstellar visitor into object requiring intelligence community evaluation. Those images never reached the public domain until someone decided the truth mattered more than classification protocols. The radio observations remained completely absent from public data releases, which made sense given that most astronomical facilities hadn't been monitoring 3I Atlas at radio frequencies during the Mars encounter. Comets emit primarily in optical and infrared wavelengths through reflected sunlight and thermal radiation. Radio emission occurs, but tends to be weak and uninteresting, mostly from molecular transitions in the coma gas. There was no particular reason to point sensitive radio telescopes at what appeared to be a routine interstellar comet. Except someone had done exactly that, and the leaked files revealed what they detected. Mars Express carries a subsurface sounding radar instrument designed to probe beneath the Martian surface for buried ice deposits. The radar operates at several megahertz, far below the gigahertz frequencies used for deep space communication. During the October 3rd closest approach, mission controllers repurposed this instrument for an experimental observation of 3I Atlas, hoping to characterize the nucleus internal structure through radar reflection. Instead, they detected active transmission coming from the object itself. The signal appeared at 1.42 GHz, a frequency instantly recognizable to anyone familiar with radio astronomy. This is the 21 centimeter hydrogen line, the most abundant element in the universe, producing a characteristic emission at this precise frequency. The line holds special significance in the search for extraterrestrial intelligence, because any technological civilization would recognize its importance. It represents a universal constant, a frequency that says we understand basic physics and chemistry. Choosing this frequency for deliberate transmission serves as an unmistakable beacon, a way of announcing technological presence through the language of cosmic chemistry. The transmission lasted 37 minutes during closest approach, beginning when 3I Atlas reached its minimum distance from Mars and continuing as the geometry carried it past the planet. The signal wasn't continuous, but pulsed in a pattern that matched the visual outgassing sequences captured in high-cadence imaging. When dust jets activated following prime number timing, radio emission intensified. During quiet periods between jets, the signal weakened but never disappeared completely. The correlation between optical activity and radio emission was absolute, both phenomena controlled by the same underlying process. Frequency analysis revealed structure within the transmission. The carrier wave at 1.42 GHz showed modulation, variations in amplitude that encoded information beyond simple presence or absence of signal. The modulation pattern wasn't immediately interpretable as language or data. but it demonstrated clear organization, repeating sequences that suggested intentional content rather than random noise. Signal processing experts noted similarities to spread-spectrum communication techniques, methods of encoding information across frequency ranges to maximize transmission reliability. The bandwidth and power levels indicated sophisticated transmission capabilities. Natural astronomical sources that emit at the hydrogen line, like interstellar gas clouds and star-forming regions, produce broad diffuse emission across large sky areas. 3I Atlas generated a narrow beam, focused radio emission originating from a point source smaller than the resolving capability of the detecting instruments. The brightness temperature calculated from the emission intensity exceeded millions of degrees, a physical impossibility for thermal radiation that could only mean coherent emission, radio waves organized and amplified through technological processes rather than simple thermal glow. Multiple receiving stations confirmed the detection independently. Deep Space Network facilities in California and Spain recorded the same signal characteristics during their tracking windows. Even amateur radio astronomers operating at appropriate frequencies reported anomalous detections during the encounter period, though without the sensitivity and frequency resolution to recognize the full sophistication of what they were receiving. The signal was real, independently verified, and utterly inconsistent with natural comet behavior. 3I Atlas wasn't just moving through space, it was broadcasting. Infrared observations from multiple spacecraft painted a thermal picture that defied every model of how objects behave in space. The basic physics are straightforward enough. Sunlight heats the side of an object facing our star, while the shadowed side radiates heat into the cold vacuum of space. Temperature distribution follows predictable patterns based on rotation rate, thermal conductivity, and distance from the sun. Planets, asteroids, and comets all obey these simple rules, their infrared signatures matching calculations that any undergraduate physics student could perform. 3I Atlas violated those rules systematically. The Spitzer Space Telescope's final observations before its retirement had captured infrared data of 3I Atlas in early August 2025. Those measurements showed temperature patterns consistent with solar heating at its then current distance of roughly 3 astronomical units from the Sun. Surface temperatures reached around 200 degrees Kelvin on the sunlit side, dropping to perhaps 150 degrees in shadowed regions. Everything looked normal, and those were the values included in public data releases. The leaked files contained infrared measurements from Mars orbiting spacecraft during the October encounter. Mars Reconnaissance Orbiter carries a thermal imaging system designed to map Martian surface temperatures. When pointed at 3I Atlas during closest approach, it detected temperature distributions that made no physical sense. Hotspots appeared in regions that should have been cold based on their orientation away from the sun. Temperature gradients showed patterns inconsistent with passive heating, including areas that maintained constant temperature despite the changing illumination geometry as the object rotated. Most troubling were localized features showing temperatures elevated 30 to 40 degrees above their surroundings. These hotspots corresponded spatially with the bright surface features visible in enhanced Hubble imagery, the geometric patterns that suggested underlying structure. The correlation between optical brightness and infrared excess indicated these weren't merely compositional variations or different ice types. something was generating heat from within, maintaining elevated temperatures through active processes rather than absorbed sunlight. Energy budget calculations revealed the impossibility clearly. The total infrared emission from 3I Atlas exceeded the absorbed solar energy by measurable amounts. An object in space can't radiate more energy than it receives unless it possesses internal power sources. The discrepancy wasn't enormous, perhaps 10 to 15% excess emission compared to solar input, but it was consistent across multiple observation periods and instruments. Natural radioactive decay from trace uranium or thorium couldn't account for the observed heating. The power levels required were orders of magnitude too high for radioisotope sources, unless the object consisted almost entirely of radioactive elements, which spectroscopy definitively ruled out. The thermal management precision suggested active control systems. Natural objects develop temperature patterns determined by their physical properties and solar illumination. 3I Atlas maintained specific temperature distributions that persisted despite changing solar distance and rotation. As it approached perihelion in late October, some regions showed expected temperature increases from enhanced solar heating, but others remained stable, as if thermostatically controlled to prevent overheating. Thermal regulation on this level requires sensors, control systems, and mechanisms for moving heat from one location to another. It requires technology operating continuously across the object's surface and interior, maintaining optimal temperatures for purposes that remained opaque but undeniably intentional. The infrared signatures didn't just suggest artificial origin. They demonstrated ongoing operation of systems managing energy flow according to programmed parameters rather than passive physics. Polarimetry analysis provided some of the most damning evidence for artificial composition, though the technique itself remained obscure enough that few outside specialized fields understood its significance. When light scatters off particles, it becomes polarized, meaning the electromagnetic waves align preferentially in certain directions. The degree and orientation of polarization depends intimately on particle size, shape, composition, and internal structure. Natural cosmic dust produces characteristic polarization signatures that astronomers have catalogued across thousands of observations of comets, asteroids, and interplanetary debris. 3I Atlas dust scattered light in ways that matched none of these natural references. The measurements came from multiple observatories conducting simultaneous observations during the Mars encounter. Polarimeters attached to large telescopes in Chile, Hawaii, and the Canary Islands tracked the object as it moved through their fields of view, measuring how its reflected sunlight became polarized. Natural comet dust typically shows positive polarization at most scattering angles, with characteristic curves that reflect irregular grain shapes and porous aggregates of smaller particles. 3I Atlas displayed an extended negative polarization branch, regions where the polarization switched sign in ways that required very specific particle properties. Laboratory experiments had produced similar polarization signatures, but only through careful engineering of particle characteristics. Spherical grains of uniform size and composition could generate the observed patterns. So could layered particles with precisely controlled refractive index gradients. Both scenarios demanded manufacturing processes rather than natural aggregation. Random dust grains clumped together through gentle collisions in space, simply don't produce the optical uniformity necessary for these polarization effects. The particles needed to be designed, built according to specifications that optimized their light scattering properties. Size distribution analysis reinforced the artificial interpretation. Natural dust spans a broad range of sizes following power law distributions, many small particles for every large one, a pattern reflecting collision cascades and fragmentary processes. 3I Atlas dust showed a remarkably narrow size peak, most particles clustering around specific dimensions with far fewer size variations than natural processes produce. The distribution resembled industrial powders or engineered nanoparticles more than cosmic debris. Compositional inference from polarimetry suggested materials that didn't match typical silicate or carbonaceous dust. The refractive indices calculated from the scattering behavior indicated either exotic ices with properties unlike water or carbon dioxide, or alternatively metallic or semiconductor particles with carefully tuned optical constants. Some analysis suggested composite grains, particles with cores of one material coated with shells of another, structures that maximize specific scattering characteristics for purposes that remained unclear but obviously intentional. The temporal stability of the polarization signatures indicated that these weren't temporary configurations. Natural dust evolves rapidly in space, particles colliding and aggregating, surfaces altered by solar wind and radiation. 3I Atlas dust maintained consistent optical properties across weeks of observation, suggesting either continuous production of fresh particles with identical characteristics or remarkable stability against environmental modification. Either explanation required mechanisms beyond passive natural processes. Most researchers who examined the polarimetry data independently reached similar conclusions. The dust wasn't natural cosmic material. It was manufactured, produced through controlled processes that generated particles with specific engineered properties. Whether that manufacturing happened through biological processes, some exotic chemistry in alien environments, or deliberate technological synthesis remained debatable. But the dust itself testified to intentional design, particles optimized for scattering light in precise mathematically determined ways that natural aggregation simply couldn't achieve. The coma surrounding 3I Atlas wasn't just unusual, it was artificial, composed of materials that required assembly rather than accidental formation. The Space Surveillance Network had been tracking 3I Atlas since March 2025, 4 months before the Civilian Atlas Survey System announced its discovery to the scientific community. This revelation emerged from metadata embedded in Department of Defense observation files, included in the leaked archive. Tracking logs showed continuous monitoring, beginning when the object crossed 8 astronomical units from the Sun, far beyond the detection thresholds of civilian astronomical surveys. The early detection wasn't luck or superior telescope sensitivity. It was foreknowledge, systematic searching of specific sky regions, as if military observers knew where to look and what they were looking for. The Space Surveillance Network exists primarily to track satellites, orbital debris, and potential threats in near-Earth space. Its global array of radar installations and optical telescopes maintains catalogues of everything orbiting our planet, monitoring for collisions, weapons deployments, and foreign reconnaissance assets. The network occasionally detects asteroids and comets as secondary targets, when they pass through monitored sky regions. But dedicating resources to tracking an object at 8 astronomical units, more than 1 billion kilometers from Earth, represented an extraordinary deviation from normal operations. Tasking orders in the leaked files showed deliberate reprogramming of surveillance assets months before public discovery. Ground-based radar installations in multiple countries received instructions to monitor specific coordinates in deep space. Optical tracking facilities shifted observation schedules to include regular checks of the incoming object's position. Even reconnaissance satellites in geostationary orbit, normally focused on terrestrial targets, were repositioned to maintain sightlines during predicted closest approach periods. This level of coordination required high-level authorization and significant operational disruption to accommodate what should have been a routine scientific curiosity. The early tracking data revealed trajectory refinements that civilian astronomers never observed. Initial orbit determinations in March showed 3I Atlas on a slightly different path than the July discovery announcement indicated. Subsequent observations documented gradual trajectory modifications over the intervening months, small course corrections that brought the object onto its eventual path through the inner solar system. By the time civilian surveys detected it in July, those early trajectory variations had been smoothed away, leaving only the refined course that would carry it past Mars, behind the Sun, and toward Jupiter. Classification markings on the military tracking files indicated special access program restrictions, security levels reserved for the most sensitive intelligence operations. Distribution lists included not just Space Force personnel, but also intelligence analysts from multiple agencies, strategic planning offices, and even diplomatic advisors. The object wasn't being tracked merely as a potential impact hazard or interesting astronomical target. It was being monitored as a matter of national security, with implications extending beyond scientific curiosity into realms of strategic concern. Pre-positioning of observation assets suggested advanced planning for the Mars encounter. Military spacecraft and ground installations had been configured for optimal 3I Atlas observation. Weeks before the October approach, communication protocols had been established, data pipelines created, analysis teams assembled and briefed. When the civilian government shutdown suspended NASA operations in early October, military surveillance continued without interruption because those systems had been prepared and funded through separate channels immune to congressional budget disputes. The shutdown became almost convenient, removing civilian oversight during the critical observation window, while military assets operated freely under classification that prevented awkward questions about what they were seeing and why they were watching so carefully. Among the 42 gigabytes of leaked data, one file stood apart through its brevity and explosive content. The document consisted of a single page, clearly extracted from a much larger report based on header formatting and page numbering, that showed it as page 17 of an unknown total. The classification marking exceeded anything else in the leaked archive. Echelon 7 appeared at top and bottom margins, a designation that didn't correspond to any publicly known security protocol. Below that came special access program identifiers and handling restrictions that limited distribution to fewer than 24 individuals across government and military leadership. The document carried a date of July 8, 2025, exactly 1 week after Atlas Survey announced 3I Atlas discovery to the scientific community. That timing was significant. Within 7 days of public identification, some organization had already conducted comprehensive analysis, reached definitive conclusions, and briefed senior officials on findings that fundamentally contradicted the natural comet narrative being offered to the public and broader scientific community. The content was structured as an evaluation summary, condensing detailed technical analysis into executive-level conclusions. The assessment opened with probability estimates calculated through methodologies that weren't specified, but clearly drew on extensive data beyond what had been publicly released at that early date. Natural origin received a 3% probability rating. The analysis assigned overwhelming likelihood to artificial construction, rating that scenario at 97% confidence based on trajectory characteristics, spectroscopic signatures, and what the document called structural coherence parameters. Specific findings were listed in terse technical language. Non-gravitational accelerations exceeded cometary outgassing capabilities by factors the document quantified precisely. Isotopic ratios indicated processing inconsistent with natural stellar nucleosynthesis. Surface topology displayed geometric regularity at confidence levels that ruled out coincidental formation. Each finding came with numerical confidence intervals and references to classified technical annexes that weren't included in the leaked files. The recommendations section revealed how seriously leadership took these conclusions. Continuous surveillance was mandated through all available assets, with specific tasking for military space tracking systems, signals intelligence platforms, and what the document obliquely called non-traditional observation capabilities. Communications monitoring received explicit mention, instructions to detect any electromagnetic emissions across all frequencies with particular attention to patterns suggesting deliberate transmission. Most significantly, the document called for immediate intercept mission feasibility studies, evaluating whether existing spacecraft could be repurposed or rapid development programs initiated to achieve rendezvous with 3I Atlas during its transit through the solar system. The final paragraph addressed information security with unusual directness. Public disclosure was explicitly discouraged pending completion of additional verification phases. The rationale cited potential for social disruption, geopolitical complications, and what it termed strategic disadvantages of revealing detection capabilities to unknown observers. Coordination with international partners was authorized on a need-to-know basis, but broader scientific community engagement was to be delayed until policy frameworks for managing artificial interstellar object encounters could be established. The document's existence proved that within days of discovery, someone in a position of significant authority had concluded 3I Atlas represented technology rather than nature. Everything that followed, the careful public statements emphasizing natural explanations, the downplaying of anomalies, the classification of the most compelling evidence, all of it flowed from decisions made in that first week of July, when the implications became clear to those with access to the complete data. The leak had exposed not just hidden observations, but the deliberate construction of a false narrative designed to buy time while leadership grappled with the most profound discovery in human history. The leaked files contained references that recontextualized humanity's first confirmed interstellar visitor in disturbing ways. Oumuamua had passed through the inner solar system in October, 2017, detected only on its way out after closest approach to the Sun. The object's unusual characteristics sparked immediate scientific debate and public fascination. Its extreme elongation, peculiar tumbling rotation, and mysterious non-gravitational acceleration as it departed the solar system all suggested something more exotic than a typical asteroid or comet. Most astronomers eventually settled on natural explanations involving outgassing from exotic ices, though many acknowledged these explanations felt somewhat forced to fit observations. The leaked documents referenced something called Oumuamua protocols, established procedures for handling artificial interstellar object encounters. The protocols appeared in multiple contexts throughout the leaked communications, always mentioned casually, as if their existence was simply accepted background knowledge among those with appropriate clearances. One memorandum from August 2025 specifically noted that 3I Atlas observations should follow Oumuamua protocols for data classification and international coordination. The implication was unmistakable. These weren't theoretical guidelines developed for hypothetical future scenarios. They were practical procedures refined through actual experience. Detailed comparison tables appeared in technical annexes, systematically contrasting 3I Atlas characteristics with Oumuamua parameters. The comparisons went far beyond publicly available data for the earlier visitor. Acceleration measurements for Oumuamua showed values substantially higher than the published scientific literature reported. Non-gravitational forces 3 to 4 times stronger than the papers that sparked so much controversy had indicated. If the leaked figures were accurate, the discrepancy between absorbed solar radiation and the energy needed to produce observed acceleration became even more problematic for natural explanations. Spectroscopic data for Oumuamua appeared in the files, despite no such observations ever being published in scientific journals. The object had been detected too late for detailed compositional analysis, departing too quickly for most major telescopes to capture useful spectra. Yet the leaked archive contained emission line measurements and isotopic ratios remarkably similar to what 3I Atlas displayed. The same inverted nickel to iron ratios, the same deuterium depletion signatures, the same complex organic molecule features that suggested processing rather than natural accumulation. Most revealing were trajectory reconstruction files showing Oumuamua's path before entering the solar system. Published analyses had traced the object's motion backward through space, attempting to identify its stellar system of origin. Those studies concluded it came from the general direction of the star Vega, but couldn't definitively link it to any specific source. The leaked military tracking data told a different story. Oumuamua's incoming trajectory had been refined through observations not available to civilian researchers, and those refined calculations showed something extraordinary. The path didn't represent random ejection from some distant planetary system. It demonstrated targeting, a course deliberately calculated to bring the object through the inner solar system at specific geometry. The acceleration anomaly that puzzled scientists took on new meaning with this context. Oumuamua hadn't been passively outgassing as it departed. It had been course correcting, making final trajectory adjustments after completing its survey of the inner planets. The object had come through deliberately, observed what it came to see, and departed under power toward its next destination. And 8 years later, 3I Atlas had followed an eerily similar path. arriving on schedule as if part of a systematic reconnaissance program that humanity was only now beginning to recognize. 2I Borisov arrived in August 2019 as the second confirmed interstellar visitor, detected early enough for comprehensive observation campaigns that Oumuamua's late discovery had prevented. The comet behaved exactly as theory predicted. Its composition matched solar system comets closely, dominated by water ice with typical carbon monoxide and dust production rates. The nucleus displayed irregular shape consistent with natural formation. Spectroscopy revealed familiar molecular species in expected ratios. Polarimetry showed dust properties matching known comet populations. Every measurement confirmed that 2I Borisov was simply a comet from another stellar system, chemically and physically unremarkable, except for its interstellar origin. The leaked files revealed that this normalcy had been remarkably valuable, though not in ways the scientific community appreciated at the time. Internal memoranda described 2I Borisov as a calibration standard, a control case against which anomalous objects could be measured. One document from September 2019, shortly after discovery, explicitly outlined this framework. Natural interstellar comets should resemble 2I Borisov in their essential characteristics. Deviations from the Borisov baseline would indicate either exotic formation environments or non-natural origins. The distinction mattered enormously for classification protocols and response planning. Detailed technical specifications extracted from 2I Borisov observations established quantitative thresholds for various parameters. Water to carbon dioxide ratios should fall within certain ranges. Dust production rates should correlate predictably with solar distance. Polarization curves should match established patterns for natural grains. Non-gravitational accelerations should remain consistent with measured outgassing levels. Nuclear rotation periods should show stability or gradual evolution from torque effects. These specifications created a checklist against which future interstellar visitors could be evaluated systematically rather than through subjective assessment. The leaked archive contained comparison matrices showing 2I Borisov parameters alongside 3I Atlas measurements. Every category revealed dramatic differences. Where Borisov showed 8:1 water dominance, 3I Atlas inverted the ratio to 8:1 carbon dioxide preference. Where Borisov dust behaved like natural silicate and carbon grains, 3I Atlas particles scattered light like engineered materials. Where Borisov accelerations matched outgassing physics precisely, 3I Atlas forces exceeded sublimation capabilities substantially. The systematic nature of these deviations ruled out coincidence or measurement uncertainty. Perhaps most significant were observations about what 2I Borisov didn't do. It showed no geometric surface regularity, no organized outgassing patterns, no radio emissions, no thermal anomalies suggesting internal power sources, no trajectory modifications beyond what natural forces produced. The comet served as proof that natural interstellar objects existed and could be recognized reliably through their conventional behavior. This validation was critical for establishing that anomalous characteristics in other visitors represented genuine departures from natural baselines, rather than simple ignorance about interstellar object diversity. One particularly candid assessment from late 2019 stated the implications directly. 2I Borisov confirmed that detection methods and analysis techniques were sound. When future interstellar visitors displayed characteristics inconsistent with the Borisov template, those differences would reflect real physical distinctions rather than observational limitations or theoretical misconceptions. The document concluded with a prediction that proved prophetic. Natural interstellar comets would continue arriving occasionally, behaving like Borisov and validating comet formation theories. But eventually, something else would arrive, something that failed the Borisov comparison systematically across multiple parameters. When that happened, the conventional explanations would no longer suffice, and humanity would face the reality that not all interstellar visitors came from natural processes. 3I Atlas had become that predicted anomaly, the object that broke the template and forced acknowledgement of what the Borisov calibration had been designed to detect. Deep in the leaked archive's historical reference section sat a file that predated modern interstellar object detection protocols by decades. The document described observations from 1991, captured during the early era of CCD astronomical surveys, when digital imaging was just beginning to replace photographic plates. An unnamed object had been detected moving through the inner solar system on a trajectory that didn't match any known asteroid or comet. The observations were fragmentary, only 3 nights of position measurements before the object faded beyond detection limits of the relatively primitive instruments available at that time. Orbital calculations from those limited data points indicated a hyperbolic path, the mathematical signature of an unbound trajectory that would carry the object out of the solar system permanently. The eccentricity exceeded 1.0, meaning it wasn't captured in solar orbit, but was merely passing through. Modern analysis would have immediately flagged this as a potential interstellar visitor. But in 1991, such objects remained purely theoretical. The concept of interstellar asteroids or comets wandering between stellar systems existed in scientific literature, but had never been confirmed observationally. The 1991 observations documented something else that made the object remarkable beyond its unusual orbit. Position measurements showed systematic deviations from purely gravitational motion. The object wasn't following the path that solar and planetary gravity alone would dictate. Something was pushing it, accelerating it, in ways that changed its trajectory measurably, even over the short 3-day observation window. The effect was small, but statistically significant. Residuals in the astrometric fits that exceeded measurement uncertainties consistently. Contemporary astronomers who reviewed the data in 1991 couldn't explain the anomalous accelerations satisfactorily. Outgassing from volatile ices seemed the most plausible natural mechanism, but the object showed no coma or tail in the images, no visible signs of the sublimation that would be required to produce the observed forces. The mystery remained unsolved, documented in internal observatory reports, but never published in scientific journals. Without additional observations or clear theoretical framework for interpretation, the detection simply became a curious footnote in observational logs. The leaked files showed that this 1991 object had been retrieved from archives and reanalyzed multiple times over subsequent decades. Each analysis applied progressively more sophisticated techniques as orbital mechanics software improved and theoretical understanding evolved. By 2010, analysts had concluded that the accelerations were inconsistent with any known natural mechanism. By 2015, comparison with Oumuamua's behavior revealed striking similarities in both trajectory characteristics and unexplained forces. By 2020, the object had been formally flagged in classified databases as possibly artificial, with notation that insufficient data existed for definitive conclusion. The trajectory reconstruction showed that if the 1991 object had indeed been artificial, its path carried it through optimal geometry for observing Earth and the inner planets. The closest approach had brought it within 0.7 astronomical units of our world, well positioned for detailed reconnaissance of a planet that, in 1991, was just beginning serious space exploration. The timing seemed almost calibrated, arriving during the era when humanity was developing technologies that might eventually detect such visitors, but before capabilities existed for detailed characterization. Most disturbing was the implication of the file's inclusion in the leaked archive. Someone maintained databases of potential artificial visitors stretching back over 30 years. The 1991 object, Oumuamua in 2017, and now 3I Atlas in 2025, formed a pattern when viewed together. They weren't isolated anomalies, but data points in a longer sequence. Systematic surveillance of our solar system by visitors whose origins and intentions remained opaque. The galaxy wasn't empty of wandering probes. Earth had been receiving attention for decades at minimum, possibly much longer, before detection capabilities existed to recognize what was passing through. References scattered throughout the leaked files mentioned programs with names that never appeared in public aerospace budgets or official space agency roadmaps. Project Sentinel appeared most frequently, always in contexts suggesting spacecraft development rather than observation infrastructure. Operation Lighthouse showed up in documents discussing deep space communication, protocols, and autonomous navigation systems. Both programs carried funding codes that traced to classified defense appropriations, the portions of military budgets hidden from public scrutiny under national security justifications. The earliest Sentinel references dated to 2007, appearing in technology development timelines that outlined capabilities needed for rapid response to transient deep space targets. The specifications were remarkably prescient, given that Oumuamua wouldn't be discovered for another decade. Required capabilities included high delta-V propulsion for reaching targets with closure velocities of tens of kilometers per second, autonomous guidance systems for intercept without real-time ground control, and instrument packages capable of detailed characterization during brief, high-speed flybys. The technology development schedule projected operational capability by the mid-2020s. Budget documents showed substantial funding flowing to aerospace contractors with deep space expertise. Propulsion system development received hundreds of millions across multiple fiscal years, focusing on high-efficiency ion drives and experimental fusion concepts that could provide the extreme velocities necessary for intercepting fast-moving interstellar objects. Communications technology development emphasized autonomous operation and high-bandwidth data return from multi-astronomical unit distances. Spacecraft bus design prioritized rapid assembly and launch on short notice, with component stockpiles maintained for quick mission activation. Operation Lighthouse documentation described something different but complementary. Rather than intercept spacecraft, this program developed what the files called persistent monitoring architecture. The concept involved pre-positioning small observation platforms at strategic locations throughout the solar system, creating a detection and tracking network far more capable than ground-based surveys. The platforms would watch for incoming objects continuously, providing early warning measured in months or years, rather than the weeks or days that Earth-based telescopes typically offered. Technical specifications for lighthouse platforms revealed sophisticated capabilities: nuclear power systems for decades-long operation without maintenance, optical and radio telescopes for multi-wavelength observation, ranging systems for precise trajectory determination, communications gear for relaying data through relay satellites back to Earth. Each platform represented miniaturized space observatory, positioned where it could maintain watch over approach vectors that ground-based systems couldn't monitor effectively. Deployment timelines suggested lighthouse platforms had been launched covertly over the past decade, piggybacked on classified military missions, or disguised as other spacecraft types. Orbital parameters in the documents placed platforms near Earth-Sun Lagrange points, in high-inclination solar orbits, and even in distant heliocentric trajectories that would carry them beyond the main asteroid belt. The network architecture provided overlapping coverage, ensuring that no interstellar visitor could approach the inner solar system undetected, regardless of its incoming direction. Most revealing were mission planning documents for potential Sentinel deployment to 3I Atlas. Multiple intercept scenarios had been analyzed, evaluating launch windows, propulsion requirements, and scientific return for rendezvous attempts at different points along the object's trajectory. The Mars encounter had been considered, but rejected as too early given discovery timing. Perihelion passage offered poor geometry. But the Jupiter encounter in March 2026 emerged as optimal, providing maximum time for mission preparation, while still enabling detailed observation before the object departed the solar system permanently. Spacecraft component manifests showed hardware already assembled and undergoing integration. Propulsion systems were fueled. Instrument packages had completed testing. Flight software was validated. A Sentinel spacecraft existed in some classified facility, ready for launch on relatively short notice should authorization be granted. Someone had been preparing for this moment, building capabilities to chase interstellar visitors and determine their true nature through direct investigation rather than distant observation. The leaked files suggested that decision makers were seriously considering whether 3I Atlas warranted deploying those carefully developed capabilities. The leaked archive contained unexpected cross-references to KIC 8462852, better known as Tabby's star, the peculiar stellar object that captured worldwide attention in 2015 through its bizarre dimming patterns. The star showed irregular brightness drops far too deep and erratic to result from planetary transits. Initial explanations involving comets or debris clouds satisfied few researchers, and speculation about alien megastructures briefly entered mainstream scientific discussion before more conventional dust-based models gained acceptance. What connected a strange star 1,500 light-years away to an interstellar object passing through our solar system wasn't immediately obvious from the file headers. But the technical analysis documents revealed disturbing parallels that pattern recognition algorithms had flagged automatically. Electromagnetic signatures detected during deep space monitoring of Tabby's star region showed spectral characteristics remarkably similar to the radio emissions 3I Atlas produced during its Mars encounter. The The Tabby star signals had been captured by radio telescope arrays, conducting long-term monitoring of the stellar system, searching for any emissions that might indicate technological activity. Most observations showed nothing unusual, just normal stellar radio output and background noise. But during several dimming events, brief radio bursts appeared at frequencies matching the hydrogen line, the same 1.42 GHz frequency that 3I Atlas transmitted. The bursts lasted only minutes and weren't repeated with sufficient regularity to establish definitive patterns, but their spectral characteristics suggested coherent emission rather than natural astronomical sources. Signal processing analysis compared the Tabby's star radio bursts with 3I Atlas transmissions in detail. Modulation patterns showed structural similarities, despite differences in signal strength and duration. Both displayed spread spectrum characteristics, information encoded across frequency ranges in ways that maximized transmission reliability. Both used specific frequency offsets from the central hydrogen line that appeared non-random, as if following shared communication protocols. The similarities suggested common origin, technology developed by the same civilization, or at least sharing design principles. The implications were staggering if the connection held up to scrutiny. Tabby's star dimming might not result from natural dust clouds, but from actual structures, massive engineering projects operating in orbit around a distant star. Those structures apparently produced radio emissions using technologies similar to what 3I Atlas demonstrated. The scenario suggested technological civilization operating on scales that dwarfed human capabilities, building star-spanning infrastructure while simultaneously deploying interstellar probes to survey neighboring stellar systems. One analysis document spelled out the logic chain explicitly. If Tabby's star hosts advanced civilization, and if that civilization uses probe technology matching 3I Atlas characteristics, then the interstellar visitor might represent reconnaissance from a species whose home system humanity has already detected through anomalous astronomical observations. Earth wasn't just being surveyed by unknown aliens. Humanity might have already identified their home base, observed their engineering projects through telescopes, and debated their existence in scientific literature without recognizing what the evidence actually meant. The connection remained speculative, based on limited signal samples and pattern matching that could reflect coincidence rather than genuine relationship. But the leaked files showed that someone took the possibility seriously enough to dedicate substantial analysis resources to investigating whether 3I Atlas represented first contact with a civilization whose presence had been hiding in plain sight for years. The leaked files themselves represented the most dramatic break from institutional consensus. But they weren't the only crack appearing in the unified front of official explanations. Beginning in late October 2025, anonymous statements started appearing on specialized astronomy forums and preprint servers. Senior researchers with decades of experience began speaking carefully but unmistakably about pressure to conform to preferred narratives regarding 3I Atlas observations. One statement from a researcher at a major European observatory described being asked to revise analysis conclusions to emphasize natural interpretations. The original draft of a spectroscopic analysis paper had noted that observed emission lines were difficult to reconcile with standard comet chemistry, and suggested further investigation of alternative formation scenarios. Reviewers from funding agencies requested softening this language, framing the unusual chemistry as merely unexpected rather than problematic for natural origin hypotheses. The revisions were presented as suggestions, but carried implicit threat to future grant applications. Another anonymous account came from a planetary scientist involved in Mars orbiter observation planning. The researcher described having access to high-resolution imaging data, showing geometric surface features on 3I Atlas nucleus, but being instructed not to include those images in public data releases. The justification cited need for additional analysis and peer review before releasing potentially controversial observations. But months had passed since the Mars encounter, with no sign that additional analysis was actually occurring, or that peer review would ever be permitted for the withheld data. A spectroscopist from a US institution detailed being removed from 3I Atlas analysis teams after raising questions about isotopic ratios in preliminary data. The measured values didn't match any known stellar formation environment, suggesting either exotic origin or potential artificial processing. When these concerns were shared during team meetings, the researcher was thanked for the input, but subsequently excluded from further data access. Official explanation cited need to streamline analysis workflows, but the effective censorship was obvious. The testimonials shared common patterns. Researchers were being steered toward conventional explanations, even when observations didn't support those interpretations. Data that suggested artificial origin or highly anomalous characteristics was being withheld from normal scientific channels. Scientists who persisted in questioning official narratives faced professional consequences, ranging from subtle exclusion to explicit threats regarding career advancement and funding prospects. Most accounts emphasized the conflict between scientific integrity and institutional pressure. These were career astronomers who had devoted their lives to understanding the universe through careful observation and honest analysis. Being forced to misrepresent data or suppress findings violated fundamental principles that drew them into science originally. But speaking out openly meant risking everything they had built, facing potential termination, loss of telescope access, and professional ostracism. The anonymous statements created a growing undercurrent of dissent within the astronomical community. Researchers began comparing notes privately, discovering that their individual experiences of pressure and censorship were part of systematic pattern rather than isolated incidents. The realization that institutional astronomy was actively suppressing evidence regarding 3I Atlas' true nature catalyzed a quiet rebellion. More researchers began preserving raw data, sharing observations through unofficial channels, and preparing for eventual full disclosure when the weight of evidence would make continued denial impossible. The leaked archive represented the most dramatic outcome of this rebellion, but it wasn't the only front where the scientific community was pushing back against enforced conformity to politically convenient but scientifically untenable conclusions. The planetary seeding hypothesis, proposed by astrophysicist Susan Falsner, received remarkable institutional support beginning in August 2025, shortly after 3I Atlas discovery became public. Major space agencies issued press releases highlighting her theoretical work. Science media published lengthy features explaining how interstellar objects might serve as ready-made planetary cores. Conference organizers invited presentations on the seeding mechanism at prominent astronomy meetings. funding agencies approved multiple grants for computational modeling and observational follow-up studies. The sudden enthusiasm seemed odd, given that Folsner's core ideas had existed in academic literature for several years without generating much attention. The leaked files revealed this promotion was deliberate strategy rather than organic scientific interest. Internal communications from late July 2025 discussed the need for plausible natural framework that could explain 3I Atlas anomalies without invoking artificial origin. The seeding hypothesis fit requirements perfectly. It provided exotic but non-technological explanation for unusual composition, rapid trajectory through stellar system, and potential internal structure that might account for some thermal observations. The theory was sophisticated enough to satisfy scientific audiences while keeping discussion safely within natural phenomena. Strategy documents outlined specific talking points, emphasizing how seeding explained various anomalies. The carbon dioxide dominance became optimized composition for captured planetary cores. The geometric surface features became compression structures from high-speed formation. The thermal signatures became residual heat from accretion processes. Every observation that might suggest artificial origin received alternative interpretation through the seeding lens, creating appearance of robust natural explanation for what the classified analyses concluded was actually technology. Folsner herself apparently wasn't party to this co-option of her research. Her published work remained legitimately focused on solving planetary formation timeline problems through interstellar object capture mechanisms. But the institutional machinery amplified her hypothesis specifically because it served narrative management objectives. By elevating seeding theory to prominence, officials could point to credible natural alternative whenever artificial origin suggestions arose. The strategy acknowledged that simple comet explanations were inadequate for 3I Atlas characteristics, while steering attention toward exotic natural processes rather than technological possibilities. The approach revealed sophisticated understanding of how scientific consensus forms. Rather than suppress uncomfortable observations directly, authorities promoted alternative framework that accommodated anomalies within acceptable boundaries. Researchers investigating 3I Atlas received implicit guidance that seeding represented the preferred exotic explanation, more fundable and career-safe than artificial hypotheses. The result was scientific discussion that appeared open-minded and rigorous, while actually constraining possibilities to predetermined conclusions that avoided the revolutionary implications of what the hidden data actually suggested. Harvard astrophysicist Avi Loeb had been arguing for years that Oumuamua's characteristics suggested possible artificial origin, enduring considerable ridicule from colleagues who dismissed his analysis as sensationalist speculation. His calculations about the object's acceleration anomaly, its unusual geometry, and the statistical improbability of its trajectory through the inner solar system were methodically detailed but rejected by mainstream astronomy as extraordinary claims lacking extraordinary evidence. The scientific community had largely written him off as brilliant but misguided, pursuing alien explanations when natural ones remained plausible, however uncomfortable. The leaked files vindicated Loeb completely and revealed that senior scientists knew it. Internal communications from NASA and European Space Agency researchers contained frank assessments that Loeb's probability calculations for Oumuamua were actually conservative. His published estimates of trajectory, alignment, precision had used cautious assumptions that understated how unusual the path truly was. When classified tracking data with higher accuracy was applied to the same statistical frameworks, the odds of natural explanation dropped even further into implausibility. Private emails between prominent astronomers who had publicly criticized Loeb showed them privately agreeing with substantial portions of his analysis. One exchange from 2019 acknowledged that the acceleration to outgassing ratio Loeb highlighted was indeed problematic, and that natural explanations required increasingly contrived assumptions. Another discussion from 2020 admitted that Oumuamua's geometry was difficult to produce through known natural processes. These same researchers had published papers and given interviews dismissing Loeb's concerns as overblown. The contradiction was deliberate rather than accidental. Scientists felt that even if Loeb was probably correct about Oumuamua's artificial nature, publicly validating those conclusions would create chaos without definitive proof. The decision became to maintain public skepticism, while privately acknowledging the evidence leaned toward his interpretation. Professional criticism served as social control mechanism, discouraging other researchers from pursuing similar lines of investigation that might prematurely disrupt the careful narrative management around interstellar visitors. With 3I Atlas displaying even more obvious technological signatures, the intellectual dishonesty of the Loeb treatment became harder to maintain. His analytical approach had been sound all along. His willingness to follow evidence toward uncomfortable conclusions had been vindicated. The leaked files showed the astronomical establishment had known this privately while attacking him publicly, sacrificing one researcher's reputation to maintain institutional control over explosive information. The revelation was damaging, not just for what it showed about 3I Atlas, but for what it revealed about how scientific institutions handle discoveries that threaten established narratives and social stability. Truth had been subordinated to politics, and the community's credibility suffered accordingly. The detailed chemical inventory from classified spectroscopic observations contained combinations that violated every known pathway for natural cosmic chemistry. The carbon-13 enrichment alone exceeded anything observed in solar system materials or meteoritic samples by factors approaching 3. Natural stellar nucleosynthesis produces carbon-13 through specific nuclear reactions, but the ratios remain constrained by well-understood physics. 3I Atlas showed values that would require formation in stellar environments that simply don't exist in current cosmological models. Deuterium depletion presented an even more serious problem for natural explanations. Heavy hydrogen forms during the Big Bang and gets incorporated into all subsequent matter at relatively constant ratios. Stars destroy deuterium through fusion reactions, but comets and asteroids preserve primordial values because they never experience the extreme temperatures necessary for nuclear reactions. 3I Atlas showed deuterium levels depleted by nearly 40% compared to solar system standards. The only terrestrial processes that produce such depletion are industrial isotope separation techniques used to prepare fusion fuel or manufacture heavy water for nuclear reactors. The nitrogen-15 enrichment added another impossible data point. This isotope forms through specific nucleosynthesis pathways in evolved stars, but again, the ratios follow predictable patterns. 3I Atlas nitrogen showed enrichment levels that would require processing through multiple stellar generations, or exposure to cosmic ray bombardment over timescales exceeding the age of the galaxy. Neither scenario fit the object's other characteristics, or the dynamics of how materials move through interstellar space. When analysed collectively, the isotopic signatures told a story of deliberate modification rather than natural accumulation. The specific combination of enrichments and depletions served no obvious purpose from a natural chemistry perspective, but made perfect sense if the goal was fuel preparation and material optimization for advanced propulsion systems. Deuterium depletion suggested fusion fuel consumption. Carbon-13 enrichment could indicate specific manufacturing processes or waste products from energy generation. The patterns matched what engineers might produce, rather than what nature creates randomly. Multiple laboratories analysed samples from the leaked spectroscopic data independently, each reaching similar conclusions about the impossibility of natural formation. The isotopic ratios simply couldn't be reconciled with known astrophysical processes. Every attempt to construct natural scenarios that might produce the observed values required such contrived combinations of unlikely events that the explanations became more improbable than simply accepting artificial processing. The chemistry didn't just suggest technology, it virtually demanded that conclusion once all natural alternatives had been systematically eliminated through rigorous analysis. 3I Atlas carried chemical signatures of industrial civilization, evidence written into the atomic composition of its materials that no amount of theoretical creativity could explain away through natural cosmic evolution. The silence around 3I Atlas' artificial origin wasn't mysterious once the incentive structures became clear. Every scientist involved faced career calculations that made public acknowledgement professionally suicidal, regardless of what private analysis concluded. Academic astronomy operates through peer consensus and funding agency approval. Researchers who deviate too dramatically from accepted frameworks find themselves isolated, unfunded, and effectively expelled from their fields through social mechanisms rather than formal proceedings. The Avi Loeb example provided cautionary tale that every astronomer understood implicitly. A tenured Harvard professor with impeccable credentials had been marginalized and ridiculed for suggesting Oumuamua might be artificial. If someone of his stature faced such consequences, junior researchers and untenured faculty had no hope of surviving similar controversy. Speaking publicly about 3I Atlas technological signatures meant inviting the same treatment. Watching collaborators distance themselves, seeing grant applications rejected, and facing potential loss of telescope access that formed the foundation of professional work. Institutional pressures reinforced individual career concerns. NASA and European Space Agency leadership had made positions clear through the classification decisions and communication restrictions documented in leaked files. Researchers who wanted continued involvement in prestigious missions needed to demonstrate appropriate discretion. Those who proved unreliable through premature disclosure might find themselves excluded from future projects. The message was transmitted subtly through assignment decisions and funding allocations, rather than explicit threats, but everyone understood the expectations. Geopolitical implications added another layer of silence. If 3I Atlas represented surveillance by unknown intelligence, governments wanted control over information flow and response strategies. Scientists who disclosed classified observations could face legal consequences under espionage laws or similar statutes designed to protect national security information. The potential for prosecution, even if ultimately unsuccessful, was enough to deter most researchers from risking their freedom alongside their careers. Perhaps most powerfully, scientists genuinely worried about social consequences of premature disclosure. If they were wrong about artificial origin, despite compelling evidence, the resulting credibility damage would harm science broadly and set back legitimate SETI research by decades. If they were correct, but announced without proper preparation, the social disruption might be severe. Many convinced themselves that silence served the greater good, that waiting for absolute proof before speaking protected both their field and society from unnecessary chaos. The result was community-wide complicity in maintaining narratives that few believed privately. Researchers shared doubts in whispered conversations, but maintained public facades of confidence in natural explanations. The leaked files represented breach of this informal conspiracy of silence by someone who decided truth outweighed professional preservation and social management concerns. October the 29th, 2025, marked 3I Atlas' closest approach to the Sun, perihelion passage at 1.36 astronomical units, where solar heating reached maximum intensity. The geometry placed the object directly behind the Sun from Earth's perspective, creating an observational dead zone that would persist for 6 to 8 weeks. Ground-based telescopes couldn't see through the Sun's overwhelming glare. Most space-based assets orbiting Earth shared similar blindness. The timing appeared almost deliberate. The most scientifically critical phase of the object's journey occurring precisely when humanity's primary observation platforms were effectively useless. But the perihelion passage wasn't completely unobserved. Several spacecraft maintained sightlines that Earth-based instruments couldn't match. Parker Solar Probe orbited deep in the inner solar system on its mission to study the Sun's corona, positioned to observe objects passing through perihelion from perspectives impossible for Earth. The Solar and Heliospheric Observatory, stationed at the Earth-Sun Lagrange, Point 1, maintained continuous solar monitoring through coronagraphs designed to block the Sun's disk while imaging the surrounding space. Stereo spacecraft in solar orbits ahead and behind Earth provided additional viewing angles. Together, these assets could track 3I Atlas throughout its hidden passage. The leaked files contained observation data from all 3 platforms, showing dramatically increased activity during perihelion. Thermal emissions spiked by orders of magnitude beyond what solar heating models predicted. The infrared signature suggested not passive warming from increased solar flux, but active power generation, internal systems coming online or ramping up to higher operational states. The energy output during peak activity exceeded the total solar energy the object could possibly absorb, indicating substantial internal reserves being tapped. Electromagnetic emissions intensified correspondingly. The radio transmissions detected during Mars encounter resumed at much higher power levels. New frequencies appeared in the spectrum, broadband emissions spanning from low megahertz through gigahertz ranges. Some signals showed complex modulation patterns suggesting data transmission or system status communications. The intensity and bandwidth exceeded anything observed during the earlier Mars phase by factors of 10 or more. Most remarkably, spectroscopic observations detected emission lines consistent with fusion reactions. Specific wavelengths from ionized helium and other fusion products appeared in the spectra during peak activity periods. The signatures matched laboratory fusion experiments and theoretical predictions for controlled nuclear reactions. If the interpretation was correct, 3I Atlas had initiated fusion processes during perihelion, either as propulsion system test, power generation demonstration, or actual refueling operation, harvesting solar wind particles and converting them to usable energy through nuclear fusion technology far beyond current human capabilities. The perihelion observations documented what appeared to be systematic power-up sequence, systems activating in organized progression rather than chaotic response to solar heating. The leaked files contained minute-by-minute logs tracking emission patterns across multiple wavelengths as 3I Atlas approached and then receded from closest solar distance. The data showed clear phases that suggested deliberate operation rather than passive thermal response. Phase 1 began approximately 6 hours before perihelion, when thermal emissions first exceeded predicted values. Localized hotspots appeared at specific surface locations, the same geometric features identified in enhanced Hubble imagery from July. These regions heated rapidly to temperatures hundreds of degrees above their surroundings, despite no corresponding increase in solar illumination that would explain the differential warming. The pattern suggested internal heat sources activating sequentially, each location coming online according to programmed schedule. Phase 2 commenced at perihelion itself, when radio emissions intensified dramatically. The hydrogen line transmission that had appeared during Mars encounter resumed at 10 times the previous power level. New frequencies activated across the spectrum, creating broadband emissions that filled available bandwidth. Signal modulation became more complex, suggesting increased data transmission rates or activation of multiple communication systems simultaneously. The radio output persisted for 47 minutes at peak intensity before gradually declining. Phase 3 involved the fusion signatures, emission lines from ionized helium and other nuclear reaction products appearing in optical spectra. These signatures emerged roughly 20 minutes after perihelion and continued for approximately 2 hours. The spectral characteristics matched controlled fusion reactions rather than natural nuclear processes, with specific emission line ratios that indicated deuterium-helium-3 reactions operating at densities and temperatures achievable only through technological confinement. Phase 4 represented gradual shutdown as the object moved away from perihelion. Systems powered down in reverse order of activation. Radio emissions declined first, dropping to background levels within 3 hours of perihelion. Fusion signatures faded next, disappearing from spectra by 4 hours post-perihelion. Thermal anomalies persisted longest, but eventually normalized to passive solar heating levels by roughly 8 hours after closest approach. The organized sequence suggested automated systems following programmed protocols, activating for specific operational periods, then returning to dormant states. The energy budget during this activation sequence was staggering. Total power output during the peak 47-minute period exceeded 100 megawatts based on observed electromagnetic and thermal emissions. For comparison, typical spacecraft like the International Space Station operate on tens of kilowatts. 3I Atlas demonstrated power generation capabilities. 4 orders of magnitude beyond current human space technology, briefly operating at levels comparable to small terrestrial power plants, while crossing through perihelion behind the Sun, where Earth-based observation remained impossible. Post-perihelion trajectory measurements revealed deviations from gravitational predictions that exceeded anything observed during the Mars encounter. Multiple tracking stations, including deep space network facilities, military space surveillance systems, and international observatories, documented systematic changes in 3I Atlas path that could not be attributed to natural forces. The object was maneuvering, adjusting its course through propulsive actions that left unmistakable signatures in the astrometric data. The deviations became apparent within days of perihelion passage as the object emerged from behind the Sun and tracking resumed. Initial orbit determinations, based on pre-perihelion observations, predicted specific positions for late November and early December. Actual observations showed the object arriving at those predicted positions hours earlier than calculated, indicating velocity increases that gravitational dynamics alone couldn't explain. The timing discrepancies accumulated systematically rather than randomly, proving they resulted from actual acceleration rather than measurement uncertainty. Magnitude estimates of the required thrust forces revealed propulsion capabilities far exceeding what outgassing could provide. To produce the observed velocity changes would require ejecting mass at rates hundreds of times higher than the visible dust and gas production. Even if the entire nucleus was sublimating violently, which it clearly wasn't based on coma observations, the momentum transfer would fall short by factors of 10 or more. The accelerations demanded rocket-like propulsion with specific impulse values, indicating either ion drives or something even more efficient. Direction analysis of the course corrections showed they weren't random adjustments, but targeted modifications aimed at specific geometric objectives. The velocity changes systematically reduced the closest approach distance to Jupiter, bringing the March 2026 encounter from the nominal 0.4 astronomical units down to 0.36 astronomical units. That difference represented deliberate targeting, refining the trajectory to achieve optimal flyby geometry for whatever purposes the object or its operators intended. The timing of these maneuvers correlated with the activation sequence observed during perihelion. Major trajectory modifications occurred during the periods when fusion signatures and high-power electromagnetic emissions were detected. The propulsion system apparently operated during the same phases when other systems were active, suggesting coordinated operation of multiple subsystems drawing from common power sources activated during the perihelion energy harvesting phase. Independent verification came from amateur astronomy networks, whose observations couldn't be classified or suppressed. Careful amateur astrometrists tracking 3I Atlas position noted the same timing discrepancies that military and NASA systems detected. The object was arriving ahead of predictions by margins that grew larger with each passing week. Some amateurs published their findings online, sparking discussions about possible navigation corrections. These grassroots observations provided confirmation independent of official channels that something unusual was happening with the trajectory. Most significantly, projection of the refined trajectory forward to the Jupiter encounter showed frighteningly precise targeting. The 0.36 astronomical unit approach would carry 3I Atlas through specific regions of Jupiter's magnetosphere past specific moons at optimal distances for close observation, and through gravitational geometry that would maximize scientific return or reconnaissance value, depending on the object's actual purpose. The course wasn't accidentally drifting toward Jupiter. It was being actively piloted toward a carefully calculated intercept that would occur in just over 3 months. December 19th, 2025 represented the optimal Earth observation window, when 3I Atlas would reach approximately 1.8 astronomical units from our planet, close enough for detailed study while far enough from solar interference to permit clear observations. The date approached with mounting tension as researchers anticipated what the object might reveal after its hidden transformation during perihelion passage. Natural comets typically show predictable changes after close solar encounters: increased dust production from fresh ice exposure, possible fragmentation from thermal stress, gradual decline in activity as they recede from solar heating. If 3I Atlas was artificial, the changes might tell entirely different stories. The leaked files contained prediction documents outlining specific observational targets for the December window. Structural integrity assessments would determine whether the object remained intact or showed signs of damage from perihelion thermal environment. Natural comets often fragment during close solar passes when internal pressure from rapidly sublimating ice exceeds structural strength. Artificial systems designed for multiple perihelion transits would presumably maintain coherent structure, showing no fragmentation or significant mass loss despite the thermal stresses experienced. Thermal profile measurements would reveal whether the temperature anomalies observed during perihelion persisted or had returned to passive solar heating patterns. Continued elevation of specific surface regions above ambient temperatures would indicate ongoing internal power generation, inconsistent with natural processes. Natural comets cool predictably as they recede from the sun following straightforward thermal physics. Maintained hotspots would demonstrate active thermal management through technological systems. Spectroscopic analysis would track chemical evolution in the coma and surface emissions. Natural comets show changing volatile production rates as different ice species sublimate at varying solar distances. The molecular inventory should shift predictably as the object cools during outward journey. If 3I Atlas maintained stable chemistry or showed compositional changes inconsistent with thermal models, that would support artificial interpretation with controlled emission systems rather than passive sublimation. Morphological observations would document any structural changes in surface features or overall shape. The geometric patterns identified in enhanced Hubble imagery from July should either persist if they represent genuine architectural elements, or gradually erode if they were transient features, misinterpreted through processing artifacts. Natural surfaces evolve chaotically through sublimation and dust deposition. Maintained geometric regularity would indicate durable structures rather than temporary ice formations. Activity level measurements would determine whether outgassing remained vigorous or declined, as expected for natural comets moving away from solar heating. Artificial systems might maintain constant or even increased activity levels powered by internal energy sources activated during perihelion. The dust production rates, gas emission levels, and coma extent would all provide diagnostic information about whether observed activity resulted from passive thermal response or active technological operation. Most critically, trajectory refinements during December Observations would determine whether course corrections continued toward the Jupiter encounter. Additional maneuvers would prove beyond doubt that something was actively piloting 3I Atlas rather than natural forces determining its path. The combination of all these observations during the December window would either definitively confirm artificial origin or provide strong evidence that exotic but natural processes somehow explained the accumulated anomalies. Either way, the truth would become increasingly difficult to suppress as multiple observation campaigns from institutions worldwide converged on the returning visitor. Mission architecture documents buried in the leaked archive revealed planning for a Jupiter intercept that extended far beyond theoretical exercises. The proposals contained specific spacecraft designs, trajectory calculations, launch windows, and payload manifests with detail levels indicating serious implementation. Consideration rather than academic speculation. Someone had devoted substantial resources to developing operational plans for meeting 3I Atlas during its March 2026 approach to the giant planet. The optimal launch window opened in mid-December 2025, providing barely 4 weeks from the date of the leaked file's release. The trajectory required departing Earth with high velocity, using a direct transfer to Jupiter, rather than gravity assists that would take years. The delta V requirements exceeded capabilities of most existing launch vehicles. But documents referenced classified systems with performance specifications matching what would be needed. Heavy lift rockets developed under military programs could potentially deliver the required payload to the necessary departure velocity. Spacecraft design emphasized rapid assembly from prefabricated components rather than traditional multi-year development cycles. Modular architecture allowed integration of proven systems, propulsion modules already tested in other contexts, communication systems derived from existing deep space missions, and instrument packages adapted from planetary science programs. The design philosophy prioritized speed over optimization, accepting mass penalties and redundancy costs to achieve operational capability within constrained timelines. Propulsion specifications indicated nuclear electric systems, providing high-efficiency ion thrust for trajectory refinement and Jupiter orbit insertion. Solar panels would be useless at Jupiter's distance, requiring either radioisotope thermoelectric generators or small nuclear reactors for power generation. The documents referenced both technologies as available options, depending on mission requirements and risk tolerance. Power budgets allocated tens of kilowatts for spacecraft operations, substantially exceeding typical planetary missions, but necessary for active maneuvering and high data transmission rates. Scientific payload focused on close-range characterization, rather than sample return or extended observation. High-resolution cameras would image surface features at scales revealing architectural details if they existed. Spectrometers would analyze composition with precision impossible from distant Earth-based observation. Magnetometers and particle detectors would search for artificial electromagnetic emissions or propulsion signatures. Radar systems would probe internal structure, distinguishing solid engineering from porous natural ice aggregates. The encounter geometry placed the spacecraft on flyby trajectory rather than orbital capture, acknowledging the impracticality of achieving Jupiter orbit insertion, while also intercepting 3I Atlas during its brief passage through the system. The flyby would last only hours, but provide observational opportunities vastly exceeding anything achievable from Earth. Closest approach, distance targeted at mere hundreds of kilometers. Close enough for detailed imaging, but far enough to avoid collision hazards or hostile responses if the object possessed active defenses. Most revealing were contingency protocols for various encounter scenarios. Procedures existed for responding to active communication attempts from the object, distinguishing intentional signals from random emissions. Guidelines covered appropriate responses to observed maneuvering or approach by the target. Protocols even addressed possibility of the object actively evading intercept or demonstrating hostile capabilities, scenarios that made sense only if mission planners seriously considered they might be approaching functional alien technology rather than inert comet nucleus. The mission wasn't academic speculation. Someone was preparing to find out exactly what 3I Atlas was through direct investigation before it departed the solar system permanently. The implications of 3I Atlas for planetary defense extended far beyond simple impact hazard calculations. Traditional asteroid and comet deflection strategies assume natural objects following predictable gravitational trajectories, targets that can be nudged through kinetic impactors or gradually pushed using gravity tractors over years of patient maneuvering. If 3I Atlas represented reconnaissance by technological civilization, every assumption underlying current defense planning became obsolete. Earth faced potential threats that could actively evade, adapt, or respond to defensive measures in ways that natural objects simply couldn't. The velocity differential presented the first insurmountable challenge. 3I Atlas approached the solar system at roughly 30 kilometers per second relative to the Sun, speeds typical for interstellar visitors, but far exceeding anything humanity's spacecraft achieve. Current fastest probes like Parker Solar Probe reach perhaps 200 kilometers per second during close solar passes, but only through gravity assists accumulated over years of orbital maneuvering. An interstellar object arriving at high velocity could traverse the entire inner solar system in weeks, providing minimal warning time and essentially no opportunity for intercept using existing propulsion technology. The course correction capabilities demonstrated during the post-perihelion phase eliminated any possibility of predicting impact trajectories with confidence. Natural asteroids follow deterministic paths, their future positions calculable years in advance based on gravitational dynamics. 3I Atlas had shown it could modify its trajectory substantially through propulsive maneuvers, invalidating any long-term predictions about where it might go or what it might target. An object that could steer itself could choose to approach Earth directly regardless of initial trajectory, rendering traditional impact probability calculations meaningless. The material properties inferred from observations suggested defenses would prove ineffective even if intercept were possible. The thermal stability during perihelion passage, surviving temperatures that would vaporize ordinary rock or ice, indicated either exotic natural materials or engineered thermal protection systems far more capable than anything humans have developed. Kinetic impactors, the primary deflection method for hazardous asteroids, might simply bounce off or fail to impart sufficient momentum to alter trajectory of such robust structures. Nuclear deflection options faced similar problems. If the object could withstand perihelion thermal environment, explosive yields necessary to fragment or deflect it might exceed anything in current arsenals. The demonstrated power generation capabilities during the activation sequence raised even darker possibilities. Systems generating hundreds of megawatts could theoretically power directed energy weapons, electromagnetic pulse devices, or other offensive capabilities against which Earth possessed no defenses. A hostile interstellar visitor with such energy budgets could potentially disable satellites, disrupt electrical grids, or deliver kinetic strikes using minimal mass at high velocity. The asymmetry was total. Humanity couldn't reach such objects quickly enough to matter, while they could potentially strike Earth at will. The intelligence dimension transformed the threat assessment fundamentally. Natural hazards can be characterized, predicted, and eventually managed through technological advancement. Intentional threats from technologically superior adversaries presented entirely different challenges. Defense required not just detecting and deflecting objects, but anticipating strategies, recognizing deception, and responding to opponents who could adapt faster than human decision-making cycles. The leaked files' references to dark forest scenarios suggested some analysts took this threat seriously, wondering whether broadcasting Earth's technological presence through radio transmissions had been a catastrophic mistake. The reconnaissance interpretation of 3I Atlas implied Earth was being evaluated, its capabilities assessed, its defenses probed, its resources inventoried. If the evaluation concluded that Earth posed no threat or offered valuable resources, follow-up missions might arrive with very different purposes than passive observation. The timescales involved provided no comfort. Interstellar travel at even a few % of light speed would take decades between nearby stars, but civilizations operating over such timeframes might plan patiently, gathering information through multiple survey missions before committing to contact or exploitation. Current planetary defense infrastructure proved laughably inadequate for such scenarios. The international coordination mechanisms barely functioned for natural asteroid threats, plagued by political disputes and funding limitations. Expanding those frameworks to address intelligent adversaries with superior technology would require unprecedented global cooperation and resource commitment. Space surveillance networks needed dramatic expansion to provide earlier warning of incoming objects. Propulsion technology required revolutionary advances to enable rapid response intercepts. Most fundamentally, humanity needed to develop capabilities for operating in hostile environments against opponents who might have been refining their technologies for thousands or millions of years longer than human civilization has existed. The leaked files suggested some planners recognized these challenges and had begun preparing responses through classified programs. But the scale of investment necessary to achieve even minimal defensive capability against interstellar threats would dwarf current space budgets by orders of magnitude. Whether governments would commit such resources based on one ambiguous visitor or wait for more definitive proof remained unclear. The answer might determine whether humanity survived its first contact with technological peers or joined whatever fate awaited species too slow to recognize the dangers lurking in the spaces between stars. The dark forest hypothesis originated in science fiction, but expressed profound logic about cosmic sociology and survival strategies. If the galaxy contains numerous technological civilizations, and if resources are finite while intentions remain unknowable, then the safest strategy becomes silence and concealment. broadcasting your existence invites attention from potentially hostile species with superior technology. Remaining hidden maximizes survival probability in a cosmos where first contact might mean extinction rather than enlightenment. The hypothesis assumed this logic drove galactic behavior, creating a silent universe filled with civilizations deliberately avoiding detection. 3I Atlas transformed this theoretical framework into operational reality. If the object represented reconnaissance probe from advanced civilization, then Earth had been located, catalogued, and evaluated by intelligence, with capabilities far exceeding human technology. Humanity's century of radio broadcasts had announced our presence to anyone listening within 100 light years. Our atmospheric composition, observable through exoplanet spectroscopy, revealed an oxygen-rich biosphere unlikely to exist without life. We had violated every dark forest survival principle through sheer ignorance that the forest actually existed and contained predators. The implications for human behavior and policy became immediately urgent. Continued radio transmission and radar operation broadcast Earth's technological status and military capabilities to potential observers. Every satellite launch and space mission provided intelligence about human space access and defensive capacity. Even seemingly innocent scientific activities, like powerful radio astronomy or interplanetary spacecraft, revealed information that hostile civilizations might exploit. The leaked files contained policy recommendations advocating immediate reduction of electromagnetic emissions and careful consideration of all space activities from operational security perspective. International coordination challenges multiplied when existential stakes became clear. Different nations might reach different conclusions about optimal response strategies. Some might advocate aggressive detection and intercept programs, while others preferred passive observation and minimal provocation. Economic and political competition that drove terrestrial conflicts suddenly seemed absurdly self-destructive when species survival might depend on unified action against external threats. Yet achieving such unity appeared practically impossible given existing geopolitical tensions and incompatible national interests. The detection paradox created additional strategic complexity. If advanced civilizations practice concealment, then any detected alien presence likely represents either technological failure or deliberate revelation. 3I Atlas being detected suggested either it wanted to be seen or humanity's observation capabilities had reached threshold where concealment became impractical. Neither interpretation offered comfort. Intentional detection might indicate the observers no longer cared about remaining hidden, because Earth posed no threat worth concealing from. Accidental detection implied the galaxy contained numerous additional visitors operating below current detection thresholds. The civilization longevity question became central to threat assessment. Any species capable of interstellar travel had survived long enough to develop such technologies, suggesting either peaceful inclination or extremely effective conflict resolution mechanisms. Alternatively, aggressive expansion might be the rule, with peaceful species eliminated early in their development. The survivors humanity might encounter could represent the most ruthless competitors in galactic ecology, civilizations that achieved dominance through superior violence rather than enlightened cooperation. The cultural impact of confirmed dark forest reality would fundamentally reshape human worldview and social organization. Every assumption about humanity's cosmic significance and future potential required revision. Earth wasn't a cradle for life destined to spread among the stars, but a target in someone else's catalogue, a resource to be evaluated for exploitation, or a threat to be monitored and potentially neutralized. The optimistic visions driving space exploration for decades dissolved into paranoid calculations about survival in hostile cosmos, where speaking up meant dying, and silence offered only temporary reprieve before the hunters found you anyway. March 16th, 2026 represented the final observational milestone, the Jupiter encounter that would provide definitive answers about 3I Atlas' true nature. Every major space agency was positioning assets for maximum coverage. Ground-based observatories worldwide had coordinated observation schedules. Space telescopes were reprogrammed for intensive monitoring during the critical encounter window. Amateur astronomy networks mobilized for continuous tracking. Never before had humanity focused such comprehensive surveillance on a single object passing through the solar system. The encounter geometry offered unprecedented opportunities for detailed characterization. Closest approach at 0.36 astronomical units would bring 3I Atlas within 54 million kilometers of Jupiter, closer than many of the planet's outer moons. This proximity enabled resolution of surface features at scales revealing architectural details if they existed. The object would pass through Jupiter's intense magnetosphere, subjecting any technological systems to particle radiation and electromagnetic fields that might trigger observable responses. Multiple spacecraft in the Jupiter system could observe from different angles simultaneously, providing three-dimensional reconstruction impossible from Earth-based observation alone. Juno Orbiter represented the most capable observation platform, despite its primary mission focusing on Jupiter itself. The spacecraft carried instruments designed for planetary science, but adaptable for close-range object characterization. High-resolution cameras could image 3I Atlas at resolutions approaching tens of meters per pixel. Magnetometers would detect any artificial electromagnetic emissions against the noisy background of Jupiter's powerful magnetic field. Particle detectors would search for exhaust signatures from propulsion systems or evidence of active shield technologies. The leaked files concluded with a single statement that captured the stakes involved. After March 16th, denial becomes impossible. Whatever 3I Atlas revealed during its Jupiter passage would be observed by too many independent platforms to suppress or explain away through classification. The accumulated evidence from discovery through perihelion and post-perihelion maneuvers had built toward this moment. If the object maintained course corrections, demonstrated additional technological capabilities, or revealed structures inconsistent with natural formation, the artificial origin conclusion would become inescapable. The timing provided no margin for extended debate or careful message management. Results would emerge in real time as observations accumulated. Social media would spread preliminary findings instantly, regardless of official communication strategies. International cooperation meant dozens of institutions would have independent access to data, preventing any single government from controlling information flow. The truth about 3I Atlas, whatever that truth proved to be, would finally emerge from shadows and classifications into public awareness. Humanity would learn whether it shared the galaxy with technological peers and what that discovery meant for our species' future among the stars.